Hey everyone, and welcome back to my channel, Girl Gone Crypto. Today I am really excited because we get to dive into everything quantum computing, which I know is a big topic. So today I've got Johann Polecsak, the co-founder and CTO of QAN. So Johann, thank you so much for taking the time to join me and come on the show today.
Hi, Leah. Thank you very much for having me. And it's a pleasure to be here. Welcome, everybody. I'm looking forward to this interview because you have awesome content and I'm actually happy to be here. So thanks.
Oh, well, thank you. I appreciate that. And so just to kick off, let's get a high-level overview of what QAN is, and then we'll kind of dive into it all from there.
Sure. So QAN is the brand new layer one blockchain platform, which means that we are direct competitors of Ethereum, Polkadot, and all these layer one solutions with many added life-changing benefits. And I'm not exaggerating here. So as you said, quantum computing is a pretty hot topic today, and that's for a reason. So if you've been following closely that quantum computing is threatening elliptic curve cryptography and asymmetric cryptography in general, and this is what all blockchains rely on, among other many things, of course. And you can find many misleading articles that quantum computing won't affect cryptocurrencies and blockchains in general. This is true. I mean, this is not true. So the exact opposite is true. Even if you are looking into it, I just wanted to jump ahead and say that finally, even Vitalik himself also confirmed that quantum computing will severely impact blockchain technologies. In fact, they are already hiring for the same algorithm which we've been using in the past 2 years and developing on a big scale. So that's actually a very good feedback for us that well, I can firmly say that the biggest competitor of ours has also realized that this is an actual threat, and they went with the solution which we've been working on in the last 2 years. So yes, this is QAN. This is one of the biggest benefits.
So we have so much to dive into that I'm really excited to explore. But before we do that, let's just go high level for a moment. You were just talking about how quantum computing is actually a threat to blockchain technology and cryptography. Can you break that down a little bit more? How exactly is it a threat? Like, should we be worried? Like, does that mean that like something's going to happen to my Ethereum or my Bitcoin down the line? Like, kind of walk us through, what is the actual threat here?
Your Bitcoins won't be stolen tomorrow, so don't fear
Exactly.
that. How it works though, because as I said, you can read many misleading articles. So especially this is the most interesting and also most dangerous misunderstanding that many people who are a bit into cryptography and they kind of know how stuff works will often say that Bitcoin, for example, is not affected because the SEJ 256 algorithm, actually double SAJ 256 algorithm, is not that much vulnerable to quantum computers. It still pretty much is. I mean, cracking it won't cost you 100 million years, but 10 million years. So it's a significant attack vector, but we still don't care because we are not going to link for that long. But this algorithm only protects the past. I mean, this algorithm is used to hash blocks, block metadata and the contents of the blocks, and to link blocks together, which means, in short, I don't want to be too technical here, that quantum computers will not be able to alter the past, but they will be able to figure out your private keys and spend your money in the future, which is the same level of threat. I mean, that's as bad as it can be, right? So what quantum computers will be capable of doing is that they will be able to take your public key and reverse that to the private key. And this is a major disaster, right? And they do this by taking the signature of a signed message. I mean, every single transaction on a blockchain, let's talk about Bitcoin, Ethereum, you name it. So whatever relies on asymmetric cryptography, A transaction is nothing else but a signed message. And once they have the signature and the data, they can figure out the public key. And from that part, they can go back to the private key and forge signatures. So in short, in a nutshell, this is the kind of problem and the attack which we are talking about.
So I'm excited to dive into what you guys are building and how what you're building is quantum resistant. But before we do that, one kind of question I would have is there a way for people to protect themselves from this kind of potential, attack vector in the future? Or in your opinion, do you think that all crypto will have to move to more quantum resistant type technology in order to be kind of unaffected?
Sure. I mean, nobody in this interview will believe me that I'm independent, but believe me, I am. And I honestly don't have a solution for Bitcoin, Ethereum, or any chain of that matter, because it all comes down to the simple question that whether a blockchain is already running on another vulnerable algorithm or not. So we only got lucky because we get to start and launch our fresh chain, which is quantum resistant from the bottom up. Because even if I had to migrate an already running system which relies on a different signature stack, then, well, I would have a hard time. I wouldn't know how to do it. Right. Because you would have to pull off really, really hard measures. I mean, either do you neglect and you say that, well, from tomorrow on, we want to accept EC signatures, only quantum safe signatures, and those people who didn't migrate just lost their funds. So you can go with drastic solutions like this one, but yeah, it's not an easy way. So I don't know how Ethereum and Bitcoin and the others will solve this, but luckily that's not my problem.
Right. Okay, so let's dive into QAN. How is what you're building quantum resistant? How is it different than other layer one blockchains?
Sure, there is the quantum resistance, and it works in a way that different algorithms are being standardized by the National Institute for Standards and Technology. And well, of course, quantum resistant algorithms are also being standardized. And the algorithm we chose is still in the list, and it's a very big competitor. So we are using lattices for this, which means that it gives a problem for quantum computers that they cannot effectively tackle. So because the current asymmetric crypto algorithms rely either on elliptic curves or factorizations of large sums into their own factors, that's being RSA. The quantum computers are highly efficient in solving those. So these work like trapdoor functions, which are easy to compute one way, but almost impossible to compute the other way around. And quantum computers change that. So we had to find an algorithm to be implemented in software, which quantum computers can not solve that easy. So it still works as intended as a trapdoor functions, even against quantum computers. So this is one big differentiating factor against the others. But this is not everything, because, well, we do believe that with blockchain security is the highest target to reach. But there comes again adaptability, because we have seen how much this world has struggled to adopt cryptocurrencies, and we are still nowhere. So really, I mean, we can see that these new institutions are still catching up, and major banks are trying to open towards this world, but they are not really going well, to be honest, from that point, what I see. And there's perfectly reasonable cause for that. And imagine yourself as a CEO of a bank or even a CTO. So let's focus on the tech part.
Right.
And would you tell your coders to start coding smart contracts in a language which has barely existed for like 5 years, 6 years, that being Solidity for Ethereum? Or would you love to be able to say them that, hey, you can use the language which you have mastered in the last 30 years, 20 years, because that's what you are good at, right? I mean, especially since these kind of contracts and platforms are handling money directly. So these are financial instruments, no matter how we see it or what the regulators say, these things have monetary value. So people in position with responsibilities are not having a really fun time by telling their developer that, well, this is some brand new language, but let's hope for the best, or how would that go down, right? It just sounds silly. So this is our next very big breakthrough, that we created an environment, a deterministic runtime environment called a virtual machine, which is the EVM, the Ethereum virtual machine in case of Ethereum,
Right.
that is able to run arbitrary code written in almost any language. So this way, these corporations can utilize their existing trusted developers who are now capable of using their own languages, by that I mean which they've been using in the past 20 years, other than learning something brand new, which they learned in a coding camp in the last 3 months, and trying to pull off something financial related, which just inherently sounds bad, right? So this is the second thing. And the third thing is that how people can start using the blockchain, because it's different to be writing code for the blockchain and operating a blockchain node. And for this reason, maybe you have noticed that there were some news recently that we published the cloud deployment applications for our stack, which will be also used with the testnet, which is coming at the end of this year. That we want to ease this process for everyone, because if you take a look at, may I ask you a question? How do you check your transactions, your blockchain transactions? So what was the way you used to see whether you have received any incoming transactions, or how your outgoing transactions are progressing? How do you do it?
Well, I guess it depends, what blockchain it's on. So like with Ethereum, I would use Etherscan usually just to kind of see that. Correct. Or, obviously I've, used my hardware wallet. So maybe I'm in the application for the hardware wallet, things like that. But yeah, different applications like that.
Correct. So the problem is that although this whole world is meant to be decentralized, it's getting so much centralized at the very first moment. That's so incredible. I mean, as soon as you click on an Etherscan transaction, you just associated your IP address with a transaction ID and the receiving wallet and the sending wallet address. So they have a huge database already. Who owns what? But this system was designed not to reveal that, but because of laziness and centralization, we are already at the point that they know everything. I mean, that's not a bad thing, but I'm obviously a privacy. Well, I wouldn't say activist, but I pretty much like privacy, and I want to respect privacy of others. So this is not something I like, but I don't blame people, because I also use Etherscan many times, because there are no tools of it, really. I mean, because it's hard. I could develop my own blockchain explorer to be run on even cheap hardware at home, which could be usable and what everyone should be doing. But there is no focus on that, because that's not generating a money stream, I guess, for the developers, or I don't know. But we want to fix these seemingly little problems, but which could be a big drawback in the future. So we focus on making this whole world accessible to everyday people, so they know what they are doing. They know what a private key is. They know how it works. So because it's not that hard, many companies are trying to present this as some wizardry or something really only they can do, which is really hard to understand, and you have to go to 6 different universities to pull off. But this is not the reality. It's actually fairly simple. You just have to be a bit interested in it, of course, but it can be easily explained how it works, and that's I think everyone's goal, to know what they are doing and to know how stuff works. So yes, this is the third thing, which is really important in our roadmap. Sorry, please continue.
No, absolutely. One thing I just wanted to ask about, to kind of touch on something you mentioned a moment ago. Obviously, you guys have your testnet launching later this year.
Correct.
But in terms of actual usage of the blockchain, since you guys are a layer 1 solution, like what kind of development do you kind of envision might happen on QAN? Like dApps, NFTs, also what kinds of things do you guys envision being built on top of QAN?
Sure. So obviously this stuff, I mean, decentralized finance, all the tokens, NFTs, as you just said it. But these things mostly depend on Solidity, which I told you is the proprietary, not proprietary, but this custom language designed for the EVM. And since we will open this up, as I told you, that coders will be able to program their smart contracts in any language, I hope that we will break out from this. So
Mm.
Really, so many doors will open up, and I'm trying to bring a really good example here, like what we could be talking about, like we really just explore the tiny part, tiny portion of the map of the whole Earth, and I think unleashing the power that you can truly build using any language which you learn. I mean, this way we will also empower web application developers or mobile application developers, because you could also write smart contracts in JavaScript, and so many new people and developers will be attracted to this platform because finally they can also code for it. That
Right.
I don't think we can even imagine what kind of new stuff will come from it. So what we really focus on is lowering this entry barrier, so more and more people, I mean developers, can enter into it, develop their applications in whatever language they know, and present it to the world so people can use them. I think this will be a beautiful thing happening.
So another little aspect that I want to dive into before we wrap up is the QANX token. Can you kind of walk us through a little bit, maybe more on the tokenomics of it and what role it plays in the QAN ecosystem? Like, just give us a little bit of a breakdown on the token.
Sure. So my personal favorite part, that's maybe because I'm a bit biased, because I had to something to do with designing this part of the tokenomics, but no, really. So I'm a developer myself, so I'll just give you a bit of context here, why this is important. I felt the urge to learn Solidity and blockchain programming for some reason, I don't know, 5 years ago, because I somehow felt this is going to be the future. But it was a cumbersome journey, you can believe me, especially because Solidity is really similar to JavaScript. So it gives you this very false feeling that you know what you're doing. You don't know. So it works in mysterious ways. And the syntax familiarity gives you this really false confidence that you know what's happening, but you don't believe me. Anyway, so what's important to make developers feel that they know what they do, they have control over it, and that they can gain monetary benefits, but not at the expense of others. And this is one of the most important part of the tokenomics, that now if someone is building a smart contract and deploys it on top of the blockchain, then they have to pay the deployment fees for it. So let's say that they will pay 10 units for their code. And when their code gets reused, I mean, you can re-import other people's work. So this is in a modular fashion. And when you import previous work of others, then the one who is deploying the new application using someone else's work, they also have to pay less. I mean, if you reuse components, you pay less in general, and you pay that not to the miners, but to the original author. So you can think of it like some kind of royalty, which encourages top quality coding, because if you develop well and you document your stuff well, other people will use it and other people will pay for you for that. And they also get benefits, because if you write something completely new from scratch, you actually have to pay more rather than if you look up something which already exists and you reuse that. So this is a very important part, and this is really unique. Other than that, obviously the consensus mechanism being proof of randomness, that will also give rewards. So the validators will get paid after validating certain blocks, but that's nothing new. So to say that the validators are getting financial reimbursements after the validation. So the most unique and really new part is this royalty-like system for the software developers, encouraging them to ship top quality code, which others can reuse.
So just to kind of wrap up this conversation, I know you've mentioned a lot of exciting things that you guys are currently working on and things that are kind of coming down the pipeline. Obviously, a testnet launching, the rapid cloud deployment that just happened. But can you just give us a little bit of an insight into what's kind of coming next for you guys, what the team's really working on and excited about? Give us a little look into what's happening next for you guys.
Well, we will also release our bridge soon. So currently our smart contract is running on Ethereum and the Binance Smart Chain mainnets. Our bridge solution is being audited and will be also released soon. But what we are intensively working on right now is that this whole solution, what I just talked about, what QAN platform is, to make it compatible with Ethereum. So this is why actually the testnet was delayed a bit. So it was targeted for earlier, but you have to respect that you cannot bring something completely new, because there's no way, even if I ship the world's best blockchain, to convince everyone to now buy a new hardware wallet, download something else instead of MetaMask. So you have to respect this thin line of legacy, I call, that you must be compatible with, so you can reach the market in a rapid manner. Because, well, it also, I like this example to bring here, that imagine if Tesla would have said when they shipped the first car that this is the most advanced, most high-tech car you can ever think of. Unfortunately, you cannot drive it on regular roads, so they wouldn't have gotten too much market share. So you have to find what you need to be, what you must be compatible with. So this is what we are working on right now, to just make it simple, add network in MetaMask, and everything will work as you have seen. This is not a simple job because, well, quantum resistant signing algorithms, so you can imagine, but we will pull it off.
That's a great analogy. I love that. So awesome. Well, Johann, it's been so much fun to have you on the show and get to really not only dive into what you guys are building at QAN, but even just to get your perspective on quantum computing. And there's obviously a lot of information out there right now. And like you said, a lot of misinformation, and just to kind of get your thoughts on all of that. And so I'll make sure to link everything below in the description box. So if people want to check you guys out, they can click through to your website and Twitter page and all that fun stuff. But Johann, I just want to say thank you again so much for coming on the show.
Likewise. Thank you very much, Leah.